Hello everyone, thanks for coming. So my name is Rémi Durafort. I'm been working on open source software since something like 2007. I've been working on VLC, V8, and now I'm working mainly on Lava. So now I'm doing mainly Python. So the goal of this talk is just to show you some stuff I learned from testing. It's my own experience testing some Lava and Lava related projects. So that's just only recommendations and ideas I have about testing in or with Python. So for me, there is different steps when you want to do some CI in a project. The first one is to have code formatting and static analysis. That's the easiest thing you can do with your code. So in Python, there is many projects and tools for doing static analysis and code formatting. I honestly try all of them, and there is even many more than that. And my personal recommendation is that most of them are useless, unless the three that are highlighted here. Honestly, if you want to do something with Python, just stick to these three ones, and you will be pretty good, in pretty good shape. So the first one is Bandit. It's a simple static analyzer. It won't find complex security issues in your code, but if it's running and if it's showing something, you have to look at it. It's likely to be a problem. The second one is Black, which is a code formatting tool. It's now becoming the standard in the Python community. So before there was many different small projects for code formatting. Now everyone is going to use Black, and more people, more and more projects are using Black. So just don't use Black. And you don't have to bother anymore about code formatting. It will be consistent. It's maybe not the way you like it, but everyone will in the Python community will know the style that is done by Black. So just use it. It's just working well. The last one is PyLint. For a long time, I thought that PyLint was honestly completely useless. That's my opinion. But recently, I look at the documentation, and there is a lot of options that you can give to PyLint. And this is a command line that I'm using currently for all my Python projects. It's just not really nice to look at. But this is enabling the tests, some tests that are disabled by default, disabling a lot of things. And with that, you will find some common issues that you might have in Python. It will find out these issues. If this command line does give an error, you have to look at it. That's really likely to be a bug. So yeah, just Bandit, Black, and PyLint, and you will be safe. You will be in good shape. Oops. Strange. The second step when you want to do tests for me is to start writing unit tests. So you have to choose a framework for unit testing. I know unittest, which is provided by the Python community, it's part of Python. You have Nose2, which is a rewrite of Nose, and pytest. If you use unittest, which is the official unit test framework, this is how you have to do. You have to import unit tests. You have to create a class that inherits from test case. And the name of this class should start by test with an upper T. And it should have methods and the name of the method should start with by test underscore something. And in order to test anything, you have to use self.assert equal, assert is none, assert true, etc., etc. That's a lot of code to just test that foo.upper gives foo. That's a lot of code. If you use pytest, this is the exact same stuff. You will test the exact same stuff. For pytest, you just need a function that is called test underscore something. And then you just use plain normal asserts. And pytest will do all the magic around it to have the same output as unit test. So just forget about all the projects, just use pytest. It's also becoming the standard. And if you look at the Nose2 documentation, I just looked yesterday. So Nose2 is a rewrite of Nose, so it's more recent. In the documentation, they say you should look at pytest. So just use pytest. Yes, that's the third level. Um, so some features of pytest, because there is many features. Before I'm continuing, this is links in the slides to the exact document page speaking about this in the documentation. Just click on it. The pytest documentation is really good. Just read it. So the first thing in pytest is that you don't have to create classes, just plain functions. You don't have to use self.assert equal like in unittest, just plain normal asserts, and it will work. And a nice feature I really found useful is by default, pytest will capture stdout and stdr. So for example, in this test, the test is printing something, or the function you're testing is printing something. If you use unit tests, you will see it will print I'm testing this, and it will print stdout, stdr in the middle, and then I finished and it's done or not. So it will be all mangled and not really nice. pytest will capture everything by default, and if the test is passing, it won't print anything. It will just print that I did that, I tested that, and it's done. If the test is failing, when at the end you will have a summary, and it will print this test failed. It will print the trace back, because it's a normal assert, so you can print the trace back normally with a lot of information. And it will print, it will split stdout, stdr, and maybe the logging, which is really nice to have when you're testing things. And as pytest is capturing stdout and stdr, you can actually test what stdout and stdr does contain. So this is what I'm doing in this test. So I'm just printing, but let's say it's a function that you test that will print something, and you want to check that this function is actually printing something on the screen. So if you use the capsys module, you can capture, read out an R, and check that out is hello and R is world. And then you do some more tests, like printing next. You capture again, and you will see next, which is really useful if you want to test user interaction or user printing. For example, I have a command line tool that I maintain for Lava, so it prints many things that the user will see. I use that to check that from one version to another, the user visible output is always the same. It's really easy to do. Obviously, you can do the same with all the logging. So when you're using the login module in Python, it will be captured by default, and you can check that it's actually printing what you expect to print. Obviously, pytest support plugins for Django, for testing Django project, testing async IO project, also giving user coverage. Pretty simple, but really useful. And as Milos was asking, it does support mocking. They call it monkey patching in pytest. For those who don't know what monkey patching or mocking is, let's say you have a function, you have a project that is doing a lot of network connections. When you do your unit test, you don't want to depend on having a server running somewhere to run your unit test. It's never really a good idea to require network connection to do tests. So what you can do is to replace all the call to the network by a function that will return always the same stuff. So instead of doing an actual request, HTTP request, it will just return immediately the value that you're expecting, or raise an exception or thing like that. So you can test, you can pretend that there is a server running on the network. Your code will not actually make a call to it, but it would get the results or get an exceptions. So technically, you can replace any functions, any built-in, any environment variables by your own function, your own value. That's really useful. So as I said, you can replace network access by just a function call that will not do any network or anything. So it will always return the same results, a success or an error, and it will not depend on any external servers or anything. It's always only on your machine. We can make it really reliable, which is important for tests. This is an example of what I just said. For those that don't know really Python, request is a well-known library for doing HTTP requests. So request, you can do get, all the HTTP world are supported. Let's say I have an application which is called app, in which I have a function which is called getJSON. This function will fetch a given URL, and it will check that the result is a JSON dictionary. But I don't want to depend on an external server. So I will call I will monkey patch, so every time someone is calling request.get, this will call my function. I'm replacing the library request.get by a call to my own function. And so when this application I'm testing will do request.get a URL and then try to see if it's a JSON, it will just call my function with this here that will just return this dictionary. That's all. So I'm not doing any network access. My code still thinks that it's doing network access, and so I can test it. And with the exact same code, just by changing this function, I can have timeouts, I can raise errors, I can return strange values, I can simulate whatever I want. I don't need to have a server that will do that for me. I can do that just by having some code here in the test. It's really powerful. It takes a lot of time to implement because you have to write some code, but that's really powerful. You can test a lot of things. So this is all the things you can monkey patch in pytest. So you can change attribute, delete, change item if you have a dictionary you want to change or an array. You can remove, you can change environment variables. You can also change a directory. And pytest will revert the change at the end of each test. So you won't contaminate one test you won't be contaminating one test by another, which is really important. Yeah, so some monkey patching use cases. So HTTP request, environment variable. If you play with signals in Python, you can monkey patch all the signals, and so you can actually test your code without exchanging any signals. If you have some timing, if you know that you have some time.sleep in your code, you can just replace by a no-op, a time.sleep 0. Or if you call subprocesses, you can just return the value. If you know subprocessor.check output will run a command line and return the output. In a test, you don't really need to do that. You just need to return a buffer with the string that was supposed to be returned. So you can test that your code is working correctly. And for the same reason, if your code is doing some file system access, like looking at etc password or trying to write to etc password, obviously you have to mock it because you can't let that in a test. So you can, for example, do that if you want. Because if you want to mock, for example, the built-in open, in Python there is a __ built-ins __ module, in which you have all the built-ins, so open, all the built-in like this. So in this example, I'm replacing the open by my own implementation of open. So if in my code somewhere I'm doing open this function, I will redirect to my own, and if I'm opening this file, I will generate that error, and this file I will generate another error. So I'm able to check errors too at the same time. And yeah, don't forget to return the real open that was saved before, or it will have an infinite loop, obviously. That was monkey patching. Okay. So we did code formatting, unit tests with monkey patching inside unit test. The third level for me is system mocking. Previously in the unit test, we were mocking only some parts of some sub-functions, some sub-modules. If we do integration tests, we might have to do larger mocking. So I guess you all know that integration testing is for testing the full system. So you want to to check errors that unittest will never found. You want to do some performance testing, such stress testing, faulty junction, this kind of stuff. So this is 2 use cases I actually did on Lava. So I tried to run many jobs in parallel to see if Lava is able to run 500 jobs in parallel, for example, why not? Or testing Lava without any boards attached to it, this kind of stuff. I will just present the first one. If you are more interested by the second one, we can talk about it later on. So, if we want to run 500 jobs in parallel in Lava, the first easy solution is to have a lot of money and to buy 500 boards, to buy something like 100 servers, to give a lot of money to the labs guy and girls, and to have spare time to fix servers that will fail, because 100 servers, you know that some will fail, and to fix a lot of boards that will fail, because 500 boards, you're absolutely certain that some will fail. That's just obvious. So it's not going to be reliable if you want to do that a lot, frequently, to test that your system is still performant. So I did that test on this machine, this one. I was able to run 500 jobs in my own machine, which is just an i7 with 4 cores, so it's a powerful machine, but just normal one. Just by mocking the right part in the system. Working. Okay. So I have to present the Lava architecture a bit, really simple architecture. So Lava is made of mainly 2 parts. The server, which is talking with the user, scheduling jobs, having the database, and the dispatcher, which is often a remote server, but it's not mandatory. This is the part that is actually talking with a device. This is the only part that is accessing a device. And this is a server, this is a dispatcher, this is a device. So on the server, you have many services, but we'll look only at 2 now. So master, because we have a master and slave architecture, so slave on a dispatcher and master on the server. The master is scheduling jobs and sending instructions to the slave. And we have the Lava logs that will gather all the logs from the different jobs. So we want to test that we can run 500 jobs in parallel. So we need to schedule. So Lava master, we have to have it running correctly. And we have to see if we can receive all the logs at the same time. So we need a Lava logs real Lava logs. The rest we don't really care about. On the dispatcher, we have Lava slaves that will, every time there is a new job, Lava slave will spawn a process, which is called Lava run. And this process is the one talking to a board. And this process, Lava run, is sending back the result to the Lava logs. So we said we don't have a lot of money, so we don't want any boards. We won't have any board in our system. We'll do it without any boards. If we don't have boards, we don't care about power control, serial relay, and FS server, we can just remove it. I'm trying to find a system that we can run tests without just removing things we don't care. But now Lava run can't work anymore because it needs access to a board. So if you look at the interaction between the different processes, Lava slave is spawning Lava run. So we just have to spawn a process called Lava run. It's not too difficult. But Lava run is sending back logs. So we have to send something. This is important. So what we can do, we can write a small program that looks like Lava run, but that won't do anything. That won't use CPU, won't use RAM, don't do any IOs. For that, we just have to have the same interaction and to really look like. So we need to have the same command line, so Lava slave can spawn it. We need to handle signals the same way as Lava run is doing. So Lava slave won't see any difference between a real Lava run and a faked Lava run. And we have to return the right value, so just XD0, it's not too difficult. And in order for Lava logs to think that we are actually doing something, we have to send logs in the right format and to take care about the speed, because it has to be consistent. There is a speed to respect, to do. And it's not really difficult. We just need to open a file on the file system and stream back the result and having some slips in between. That's all. We just need a process that looks like the real process from the external world. And with that, we can actually test that this is, we can run a fake 500 devices on this machine, and it's working, just by faking the interactions. That was all for system mocking. The last stuff, Dan will be happy about it. This is the fourth level for me in testing. I never did that. It's called chaos engineering. I will just read this sentence because it has been invented by some Netflix engineers. So the intent was to move from a development model that assumed no breakdowns to a model where breakdowns were considered to be inevitable. So instead of hoping that nothing will break, you have to develop thinking that if something will break, which is really different. So in order to do that, they created what they call the Simian army, which is made of different programs. The well-known, the one which is the most known is called Chaos Monkey. It's a process that will connect to random server in the data center and just shut it down on a production system. I'm not kidding. Netflix is actually at that right now, shut it down server intentionally, randomly in the data center. And they made that on purpose because the developers, they know that this is happening, so they have to work to develop and to have an architecture that is resilient against these kind of issues. And they created other projects in this Simian army, like latency. There is a latency monkey that will add latency to the network connections. Many different errors. They will inject on purpose errors on the production system. And they will check, they monitor the system, so they will monitor that it's self-healing, it's resilient, and it's still working. And it does work. That's difficult to do, but it's a really nice thing to do if you can do it. I have 3 minutes for questions if you want.
Thanks. When you're doing stuff in PyTest, is there a way where you can basically set it up so that if you do not want to mock everything, so you basically, I understand you want to mock everything when you're doing a unit test, but if you want to do a slower test run where you're actually talking to external services, is there a simple way inside of PyTest to basically say, mock in this case, but not in that case, command line flag or something like that?
Okay, when you do mocking, it will be done per test.
Right.
So it's really in your test that you will have to write the right mocking function.
Okay.
But you can have in your test at the beginning say you can have activate monkey patching and then change it and then change it and deactivate it. So if you just want to add latency or things like that, you just have to save the initial function and to call it a bit slower or this kind of stuff. Honestly, monkey patching or mocking the same is really a lot of try and hacking.
Sure. Okay.
Yeah. But you can do a lot of things. You just have to know a bit how Python is working to do that.
Cool. Thank you.
Is there an easy way to convert a project that's using unittest to use pytest?
It's compatible.
So
pytest knows how to run unittest.
Okay.
To run tests that are made for unittest. So currently in Lava we have 95% of the tests that are unit tests, so with classes and self.assert equal, things like that. And pytest knows how to use it. So you will have the nice output capturing stdr, stdr without changing anything on unit test. And when you create a new test, that's what we do in Lava. We write using pytest syntax. You should use pytest.
The static code formatters and linters and stuff, do you run all 3 of those together? And how long, if so, did it take you to get all of them to agree on? I've had problems when having multiple at the same time and they disagree on stuff and you have to do work to make it all work together.
Yeah, if you use black and pylint without any arguments, they won't agree. Pylint by default, so if you don't specify any arguments, is really picky on the syntax. And if you use black, pylint won't be happy. But if you use the command line I'm setting, which technically disable everything regarding code formatting, it will work.
Thanks.
Another question? Thanks.